So today I'm going to talk about Algebra 3 review assignment. We're going to go over the section 1 of this. And section 1 is discussing lines. Now, it's probably been a long time since you have actually talked about anything that has to do with lines or linear equations and such. So this stuff's probably going to be very rusty in your bag of mathematical knowledge right now because it has been so long. So let's go through each one of these equations, make sure you understand what they mean, and then I'll give you a couple of examples here that go along with them. First, in section 1, they have the formula for slope. And as you can see right here, anytime you have an m, that m represents slope. So for instance, in the next equation, slope-intercept form, the m right there is representing the slope. And the way that we calculate slope is we subtract the y values and then subtract the x values, and you have two numbers which turn into a fraction. So as a general rule, you would have x1 and then y1 as your first ordered pair, and then you would have x2 and y2 as your second ordered pair. And then to find the slope in between those 2 points, you would simply do y2 minus y1 and then divided by x2 minus x1, and that would give you your slope. Yes, you should reduce the fraction if it's necessary. Now, the next equation is slope-intercept form, which is y equals mx plus b. Slope-intercept form needs two pieces of information in order to have a complete equation, which one, you need your m, which is already highlighted, and then two, you need your b. If you don't remember, b stands for y-intercept. The y-intercept is where the actual line crosses the y-axis. So it could be a positive number, or it could say minus whatever, 2. Could be a negative number. It just depends where the line crosses the y-axis. So slope-intercept form was probably the first equation that you were introduced to as far as linear equations go. It is very useful, but there are some limitations to it. Mainly, if they give you the slope, but they only just give you a point, they don't actually tell you where it crosses the y-axis, you have to it's a little bit longer to find the equation in that case because you don't have the specific y-intercept. And that, I'm going to skip standard form for a second. That's where point slope form comes in. Point slope form is very useful because you only need the slope of a line and then some point anywhere on the line. And so, as an example, if you knew a slope of an equation was 3 and you know the point it went through -4, 5, you could take this information and plug it right into point slope form and then have an equation. So it would be y minus, and be careful here, this is where people usually make a mistake. Make sure for y1 you actually put the y value of the ordered pair, which in this case is 5. Then you would have 3x minus -4. And that would simplify into y minus 5 equals 3. I apologize, I'm running out of room. 3 and then x plus 4. And that would be your equation in point slope form. If you did need to convert that into slope intercept form or standard, you would need to distribute the 3 to both things and then move your terms to the left or the right side depending on which form you're going for, standard or point slope form. Now let's look at standard form for a second. Standard form, this equation actually should have a capital A right here. And this should be a capital B right here and a capital C right there. So it should say capital AX plus capital BY equals capital C. A couple things to remember about standard form. The A, the B, and the C, so the constant coefficients, those cannot be negative. I'm sorry, just A can't be negative, but they also cannot be fractions. So an example of a proper standard form would be like 2x plus 3y equals 6. That's good. 2, 3, 6, none of those are fractions, so you're okay. And the first number cannot be negative. So there's a proper standard form. of an equation. To put that into slope-intercept, for instance, you would want to move the 2x to the other side and then divide both sides by 3, and then you'd have a y by itself, which would give you slope-intercept form. The intercepts, in order to find the x-intercepts of an equation, you have to set the y value equal to 0 and solve the equation for x. In order to find the y-intercepts of an equation, you have to set the x value equal to 0 and solve for y. So let me give you an example of that using the standard form above. So if we start with the 2x plus 3y equals 6, if I want to find the x-intercept, I'm going to let y equals 0. So it's going to be 2x plus 3 times 0 equals 6. So the 3 times 0 goes away, and you're simply left with 2x equals 6, which gives me x equals 3. So what that tells me about that equation, that 2x plus 3y equals 6, is this equation will cross the x-intercept at 3. Now, the y-intercept is going to be done in a similar fashion, but you're going to let x equal 0. And so when you let x equal 0, you get 2 times 0 plus 3y equals 6. 2 times 0 crosses out. You have 3y equals 6, which is y equals 2. And that tells you that that equation will cross the y-axis at 2. So just a quick little sketch in here. It's going to cross the x-axis at 3. So we'll put a dot there. It's going to cross the y-axis at 2. So you'll put a dot there, and then you'll draw your line. And you have a quick graph of that 2x plus 3y equals 6. A couple things to note. Parallel lines. If two lines are parallel, they have the same slope. So if you know one equation is supposed to be parallel to another line, that tells you that other line has the same slope as the first equation. Perpendicular lines have slopes that are opposite reciprocals. So in other words, as an example, if I had a slope of 2/3, the perpendicular line to that would be -3/2. Um, so the two words opposite means if the first one's positive, the second one is negative, and vice versa. The first one's negative, then the second one's positive. And then the reciprocal, of course, means to flip the fraction over. So, all right, there you go, guys. I reviewed over all the review concepts at the beginning of section one. Please take some time now and work through the first set of problems that I have assigned on Google Classroom. Again, we're going to be live tomorrow, and I'll be able to answer any of your questions. I do expect there to be a good many questions on this, since it has been such a long time since you've probably thought or done anything with linear equations. So take care, and I will see you tomorrow. Thanks.